लेक्चर 2 स्टार्ट करवा दीजिए, स्लाइड था लेक्चर 2 सेकेंड डे का डे 2 डे 2 या क्या था लिखा हुआ डे 2 था ना क्या था नहीं डे 1 का लेक्चर 2 होगा शायद नॉट डे 2 डे 1
लेक्चर 2 ही चल रहा है सर नहीं लेक्चर 3 होगा ना अभी
वो लेक्चर 2 हो गया
लेक्चर 2 हो गया सर
ओके ठीक है
मतलब हम YouTube पे तो 2 हो गया सर जो पढ़ा रहे थे वो 2 ही चल रहा है
2 ही चल रहा है
जी सर 2 में थोड़ा स्लाइड बाकी है उसमें फिर हो जाएगा
ओके
बस चलिए YouTube के लिए सर 3 स्टार्ट हो गया
ओके
लेकिन हमारे लिए ये 2 ही कंटिन्यू होगा
ओके
सर तो हम करते हो कि इसमें स्टॉप करना पड़ेगा 2 कंप्लीट होने के बाद स्टॉप करना पड़ेगा नहीं तो उनका यम नहीं मिलेगा मतलब एडिटिंग में ना सर ना 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 सर 2 पूरा बाकी है ना कंप्लीट
ठीक है 3 कर दो
3 होगा स्टार्ट
ये है क्या लगता है खाना के बाद सब सोने चला गया एवरीबडी इज स्लीपिंग एक्सेप्ट यू जनरली स्टूडेंट लोग आफ्टर लंच दे लाइक टू स्लीप तो हो सकता है आधा घंटे बाद आया
आएगा सर लैब वगैरह है तो वो स्टार्ट करके 3:30 4 तक
ठीक है एनीवे लेट्स गो अहेड लेसन 3 complex network challenges in 6G so we will have the challenge okay multi network convergence in 6G you are familiar with the multi network no okay that is so multi network convergence in 6G refers to the integration of you are familiar with a heterogeneous network how many of you know heterogeneous network
so basically heterogeneous network is a network where similar kind of things are situated things in the sense network for example you might find a terrestrial network you might find a small cell you might find a normal cellular network so when all these coexist together in a single network then you call that as a what to say then you call that as a heterogeneous network okay.
is it clear to you more than one network combined together becomes heterogeneous network I was doubtful that heterogeneous perhaps they don't know but you are PhD student no who is PhD here okay they are the PhD student so including देखो heterogeneous if you say including terrestrial communication non-terrestrial satellite short range into a seamless intelligent 6D ecosystem so this is heterogeneous it enables ubiquitous always on connectivity for devices even in rural remote or disaster prone areas the plus point of heterogeneous that you can cover everything if you have only one aspect maybe they can cover only city or village or both but not everything once you have the heterogeneous coverage is everywhere so now it is called integration of terrestrial and non-terrestrial network what is terrestrial network I think all of you know terrestrial network everybody knows about terrestrial network no yeah like mobile phone what we are using it is terrestrial network so base station fiber optic backhaul edge and core network traditional cellular tower you have seen the towers then 5G 6G RAN massive MIMO and beamforming then non-terrestrial LEO satellites for global coverage so hubs high altitude platform stations and coverage there use cases in delivering broadband to areas lacking terrestrial structure wherever you find that, for example, cellular network will not cover, satellite network will cover. Internet of Things, I think all of you know Internet. Embedded sensors, connected devices in industries, agriculture, healthcare rely on both terrestrial for consistent connectivity. So 6G goal, what is the 6G goal? What is the 6G goal? Anyone can tell me 6G goal? Any one of you? I think only one can tell. He is the person who can tell 6G goal. What is the goal of 6G?
Provide ubiquitous connectivity. So in ubiquitous connectivity, you should have broader coverage. Like you can connect, say, one continent to another continent, and that way it is possible. So with the help of integration with terrestrial network to non-terrestrial network, we can realize that.
Very good. 6G, the main advantage is it globally it covers everything. Like till 5G we don't cover. 6G covers everything. And that is what he mentions to you. The terrestrial communication, satellite communication, space communication, it covers all the aspects. So 6G goal, he mentioned that is correct. But overall, it has an intelligent adaptive system, dynamically choosing best routes and access methods. So one is that what is the best mode to connect one to one? That is what it selects 6G. Otherwise, if it does not, it takes more time, more expensive. So use cases is everywhere. Any topic you cover, there must be applications. So one is emergency and disaster response. That is very, very important. Something emergency happens. Can you say anything emergency? What is the emergency? One of you, what is the emergency application?
Tsunami happened somewhere. Some earthquakes happened or natural calamity, maybe cyclone in that area, or the cellular network will cease to exist. In that case, we need to have a emergency communication.
Correct. Any other example for emergency? All of you are young. You should say what is emergency. For example, I fall down here. I'm an 80 years old professor. And since morning I am working, there is a good chance that I may fall down. This is also example of emergency. Oh, say. So most important is global 6G roaming, transparent transitions across network types. So it does not mean only one network when 6G talks. It is a heterogeneous network. It is what we mentioned in the beginning. Challenge is everywhere. Whenever you talk new topic, challenge comes. So 1, 2, 3, 4 challenges are there. Bandwidth and spectrum management. Any technology we develop in telecommunication, a spectrum is the paramount issue. And if you go to the Department of Telecommunication, there is a special group for the spectrum people. Think about the spectrum, they decide about the spectrum, they sell their spectrum, government earns the money. So whether we had 2G or 3G, 4G, for every generation, government earns billions of rupees for their spectrum. It is so expensive affair. So diverse spectrum requirements across NT and terrestrial, risk of interference, inefficient use, and regulatory conflicts. Regulation is very important in the case of a spectrum issue. What is the regulation policy of Government of India or any government for that matter? That is very key issue. Latency and delay constants. Then security risk. So latency and security, these two parameters will find everywhere when we talk about applications, regulations, and everything. Then mobility and handover complexity. Handover was very important when we were talking about 2G, 3G. How to go for handover. Handover was the most important topic to do research in those days. So yeah, so these are the 4 issues which we challenge for the 6G network convergence.
One question. be considerable propagation
Hmm.
delay. You need to travel some distance. Uh, like when we compare this propagation delay with the fiber network,
Hmm.
so what is your opinion? Which one will be more suitable? Connecting through fiber network that we have from one continent to another continent, or we should prefer the non-terrestrial network?
I think we should prefer non-terrestrial aspect. But fiber will be very expensive affair.
But it is already that we have
It
as
is,
a first platform.
we have, but the, when we launched the fiber network, purpose was different. Now we have more technology and more applications. There, that fiber network will not work. You have to again launch the fiber network separately. It will not function what we have today, and that becomes very, very expensive affair. What is your opinion? This is my opinion.
Based on situation, like like if I consider this NTN,
Hmm.
somewhere the connectivity is there, then it is well suited.
Hmm.
If it's not there, then we need to rely on the partner.
That's true. That it becomes, but anyway, they are complementary function. Fiber and wireless, they are complementary each other. Then latency, we talk security aspect. Each layer has unique attack surfaces. Satellite, then UAV, then IoT. 6G requires zero trust models and post-quantum cryptography. Then mobility and handover. As I told you, handover was very important when we were talking about 2G, 3G, and so on. So seamless handover between UAV satellite. Here, in the case of 2G, 3G, between cellular communication, we had the problem. Here, the handover becomes satellite to terrestrial and so on. So issue is very different. Challenges: maintaining quality of services, session continuity, and billing integrity. Evolution of RAN to Open RAN in 6G. There, evolution of RAN to Open RAN. What is the difference between RAN and Open RAN? Anyone of you can teach me difference between RAN and Open RAN?
So earlier, whatever equipment that we used to buy buy for that particular operation, say for radio access network, these were proprietary and we were not allowed to make any changes. Nowadays, we are preferring, say, something from some company and other thing from some company, and they are like providing the system that we can customize.
Right.
We can change as per our requirements. So most of the things are now having the standard that are. You can take example of Type C mobile charger. So they are having the same thing. If you buy from Samsung, Nokia, or any company. So the similar way we have facility with OpenRAN, we can like have software from one company or source code from one company and hardware from other company. That's the flexibility we can have.
So Open RAN decouples hardware, that is what we were mentioning, hardware and software, enabling programmable, cost-efficient, and AI-driven radio network. Here is the traditional RAN, Open RAN. Component are vendor, of course. Who is the vendor? Architecture, flexibility, innovation pace. Traditional RAN, particularly single vendor. Maybe Siemens, maybe Nokia, maybe Ericsson. Monolithic, fix the hardware, software, slow. Now, Open RAN, what we have, multi-vendor is possible. That's a plus point. Then, of course, it can be modular. It can be software defined. It can be software defined radio, you must have heard. And fast via OpenStack. Already ORAN, we explained it, and this is what we have discussed in the slide. ORAN, Open Radio Access Network. I think all of you know RAN full form. Anybody who does not know the full form of RAN? What is the full form of RAN? It is already written here. But everybody knows what is RAN. So Open Radio Access Network is an industry initiative, an architecture that aims to open up and standardize the radio access network components of cellular networks, particularly in 5G and future 6G system. So ORAN will play very important for the 6G applications. What is the key goal? Open interface, disaggregation, virtualization, intelligence, and automation. These are the key goals what we have, like intelligence. Use AI ML. I think AI and ML everybody is familiar, to optimize network operation in real time. Virtualization run functions on standardized hardware using software. Disaggregation, separate hardware and software layers. Name is disaggregation. So very clear. Enabling flexibility and cost savings and so on. So these are the plus point for the ORAN. Key component of 6G RAN. Now we are talking about 6G and what are the key components? Radio unit, distributed unit, centralized unit, and virtualization aspects. So in the case of radio unit, handles radio frequency function. In the case of distributed unit, real-time layer for data processing. In case of centralized unit, aggregate data and manage control functions. Last but not least, virtualization allows this to be placed flexibility across the network from edge to cloud. So flexibility is very important parameter which it allows that was not happening in earlier technology. So we are discussing all the Open RAN, and there will be good question for your examination on Open RAN then. I just lick the question. And for licking the question, he should get, he is allowing me to lick, so he should get 1,000 rupees or 10,000. 10,000 is a student should give him. Opportunities with Open RAN in 6G, here network slicing, spectrum sharing, AI-driven optimization, vendor diversity and innovation. Anyone, if you like innovation, who likes innovation? Raise your hand. Only 2, 3, 4. I think all of you like innovation. Please raise your hand. Innovation. If you don't like innovation, how can you grow in the technology field? So innovation is a very important aspect. So vendor diversity innovation encourages competition, because everybody has innovation, naturally will have competition. Avoids vendor lock-in and accelerates upgrades. So really, it is very important aspect in life, not only for the technology, even for example, you are a student and you have to compete that somebody gets 100 by 100, somebody gets 90 by 100, then you try to compete with him and get 100 by 100. Have you ever tried to compete? You didn't try? How many of you have got 100 by 100 or 90 by 100? Any one of you? 90 by 100 or 100 by 100? See, that is possible. AI-driven optimization, use machine learning agents to predict congestion. That is a really critical point. Optimize handovers, reduce energy consumption. All three very important aspects. Then the spectrum sharing. As I told you, spectrum is the very expensive parameter for telecommunication. And really every government, whether it is government of India or government of Denmark, they have the problem about spectrum distribution. Whenever new technology comes, how the spectrum should be distributed among the different operators. It is not easy task. And as the operator compete, cost goes higher and higher by the government of India or government of Denmark. Network slashing, dynamically allocate network resources for different use cases. For example, healthcare. Your healthcare is coming everywhere. I didn't know that everywhere in my slide healthcare is written. So it looks you have prepared my slide. Challenges. So interoperability, different vendor or components may not work seamlessly. Interoperability is very important aspect. And different vendors you have, naturally they are trying to compete each other. Every company wants to earn more money than others. Nokia, Siemens, Ericsson, whatever company comes forward. Security, open interface introduce new attack vendors. Integration complexity, coordinating multiple vendors adds testing burden. Last but not least, real-time requirements Virtualization may delay time-sensitive radio processing. So these are the challenges we have: interoperability, security, integration, and real-time aspects. Any other challenge we can include here? Is it enough or we need some more challenge? What do you think? 1, 2, 3, 4 is written. I think one more should come. 5 is a good number. Who can tell me the fifth challenge?
Cost should be minimal.
What should be? Cost point of view. Sounds good idea. Any other point for the challenge? Latency. That's also key parameter. Any other point? I think we should make 7 challenges. It was 4, now 2 added. What can be the 7th? Yeah. So these are the other challenges, because it is not enough what I have written in my slide. There are more challenges we have. So after covering every topic, there is a slide key takeaways. What you take away to your home to understand it further. So 6G network aim to integrate terrestrial, satellite, and IoT into a unified intelligence system. That is the key feature of 6G, that we are covering all technology together. Network convergence introduces unique latency, spectrum, and security challenges. Open RAN will be a foundational architecture for programmable AI-enhanced 6G deployment. Last but not least, emphasis on multi-vendor ecosystem, as we mentioned, network slashing, and sustainability. These are the key takeaways. 1, 2, 3, 4. I don't know why everywhere I have put 4 only. It can be more than 4 takeaway. What do you think? What additional takeaway you can take from this topic? 6G challenges. There must be at least one more topic to be added in the slide. Whatever I am listening, I will try to add new slide for my next talk anywhere in the world. Anybody coming with new topic? Key takeaways, I have put only 4. 5 is a good number. Anyone is coming up? I think everybody is serious and nobody is replying me. What is missing here in the slide?
Role of AI is
Already there. I think if anyone is not coming forward, I think they should add cyber security also. That is a very important aspect that should be added in the takeaways. Because almost every slide was talking about security, and it is not here. That is the spectrum security. But the cyber security is a bit different. Because 6G cyber security is very important. Do you understand the meaning of cyber security? Do you understand the meaning of cyber security? How about you?
So we deal with some of the cybersecurity challenges. For example, phishing attack, some of the firewall-related attacks, some of the network attacks we deal with, but not so much technically. At least I am not so much aware of it technically. But some of the things we know. Say, for example, simple phishing attack would be somebody writes an email with your own name, maybe, and then forwards it to everybody in the network. So even though you might find out, say for example, your photo, your name, but the email ID at the last is
a lot of things are happening.
So these are some examples.
Yeah.
Of what,
I think it should be added here.
Yes,
It should be added.
can be added.
Yes, please.
Cybersecurity mainly we can say that the end user should have the security parameters rather than like in backend we can integrate the things in as per for the benefit of end user. More centric for the end user.
That can be added. Yeah. Any other point to be noticed which I am missing here? I put only 4. One point came forward. Any other point do you think?
I think even though Open RAN is has various advantages over RAN, even though it improves the 6G architecture, but obviously it has its own compute, it has its own complexity in terms of money-wise. If you have to deploy an Open RAN architecture, it would be more costly.
You will become a good businessman.
I think
You think you are a good businessman. I think that should be also added, I think.
that could be one.
So new slides should add these 2 points.
One point, yeah. This point.
Lesson 4, Society 5.0 SDG 6G network.
Sir, we have still half an hour, so we have to start it from 4 o'clock.
We have to make a break.
Yes, sir. From 4 we have to start.
What is time now?
3:30. So maybe 15 minutes of discussion of this, and then
So we should go for discussion.
yes, 15 minutes of the earlier topic,
Hmm.
4 minutes
And then we break and then start. Okay,
some discussion.
some discussion. Or discussion I will put among all of you who want to raise a question to everybody. You want to start discussion? It looks you have good discussion ability. So discussion topics should be such that everybody should get involved.
In terms of, I will like
Address to people, not to me, because you are not discussing with me, you are discussing everybody.
since you guys are familiar with latency, so do you think there will be a certain point where there will be no more research policy in terms of latency? Because the ultimate lowest latency we can get is 1 microsecond or something. So do you guys think there will be certain like limitation on research on latency? Because in 6G we are relying on low latency. I think, in my opinion, there is always a limit because we cannot neglect the propagation delays.
Yeah, that's very.
Propagation delays will always be there when we talk about, say, larger coverage area. It is certain. That is actually key point when we decide between FDM and TDM. The division, time division, duplexing, and TDD and FDD.
Yeah.
So because of that only we prefer FDD. Although FDD is complex and little bit expensive, but because of the delay that it introduces, we prefer FDD. So I think there is a limit, and beyond that limit, we cannot reduce the latency.
Yeah.
This is like my opinion.
How about other people? Any other comment? Here there is a good point to discuss now. Yeah. Please raise to him. But
There is a limit obviously because of the hardware, because of the material that we are using. But I like if we are going for like quantum communication, then that the delay or latency ultimately cease to exist because our ultimate goal is to actually have an instantaneous communication. Like as if right now we are talking, so other people who are not present here, they should receive exactly the same communication that others who are sitting exactly here, so that sometime in future that's going to happen. In that case, there is no latency. Like those who are here, the latency is basically due to their perspective position. Now, if you consider there is a video recording transmitted somewhere, like you are watching a match, there is a latency, and you are feeling okay, ball has been played. If you are following info, then there is an update, and if you are following a video, there is an update. There is a delay. But if you are there in the match stadium itself, you will not feel there is a delay. You will see exactly that things are happening. So maybe in quantum communication, that delay latency will not be. So our aim is to actually reduce as much as possible. Right now we hello maybe in some microsecond because of the material that we are using, because the technology that we are using. In future there will not be latency.
I have one more follow-up question.
yeah, please go ahead. We have time.
If we are all in a room, suppose someone is standing there and
And you can bring one more topic for discussion.
even what I speak, even my voice is reaching him with certain delay. So do you guys think there will be a time when our communication system will come to a technology where we can reach to that person through communication faster than in person?
Yeah, obviously, like if you see like, what I think of, like
Because
right
sound has
now,
certain limits,
yes,
certain speed.
yes.
So there will be latency there.
So that is happening because we individuals are using language as a communication medium. The moment we will be using
or thought to communication, then there will be no requirement of actually having a sound because of media, there's a delay. That will not be there. The thought transportation, like if you think of in that line, then it is possible. Now it is possible in quantum level. The teleportation, tele-transmission is possible. And maybe in future it will be possible to have a directly communication. In that case, that delay will be non.
Quantum itself.
I think.
You have any other topic to discuss? I think you are playing a very good role. Can you raise a point to discuss among the colleagues?
Also, just I was thinking that when you talk about the issue,
Please come here so that everybody can listen to you.
so like open RAN, one of the advantages that you can use network functionalities from different vendors. Now, because right now there is if you are taking from some solution from some vendor, some solution from other vendor, and you do not know that some vendor, because of their business model, they want to actually exploit your network. So there's an issue of there will be integrity issue, and also there is a threat possible because of the traditional design of open network. Because network ideally designed, some of the system we as human beings are not actually up to the level that where the freedom and everything is given. We are will be using for our everybody's benefit. We tend to take benefit from the whatever there is a future. So open RAN maybe if it is like vendor is studying like right now we are suspecting some hardware is that Trojan softwares are there in the hardware and we do not know that what communication that you are making that is already transmitted to some other country. So some countries are using this method. So open RAN that issue is there. It's not about this cyber security. Some aspect is already there, but you can exploit the network if you are designing the network.
Anyone would like to argue with him? If not, then some idea for discussion.
Actually, I just want to highlight one important aspect based on the key takeaways that I've mentioned. So, first, the takeaway is 6G network is expected to integrate terrestrial, satellite, and IoT networks with having some intelligence. So, considering the requirement, what will be the hardware challenges that we will have considering these as objective into our phone and devices like smartphones. So, what do you think? Like, is it feasible to integrate all these things in just one compact device? Or what's your opinion?
Any question to him? Any one of you want to raise a point to discuss?
Because like if we consider terrestrial communication, we need different set of hardware. If we consider satellite communication, because the operating frequency is different, challenges are different, so we need different set of hardware. And then for IoT, we have different hardware. So, like integrating all these systems into one chip or like system, what challenges we may face?
That's true.
I think that might be possible with the not centralized procedure. That type of centralized procedure that will process.
No, I'm talking about this, like, our smartphone.
Yes, sir. In the smartphone, if we can use satellite communication in smartphone, then we really need terrestrial communication because starting doing that thing only. Through satellite communication is just giving us the freedom to do every communication in our phone.
No,
So
but
do we need to
But
integrate
with satellite communication, if you are inside the building, I think the connectivity will be lost.
Yeah.
So even though if your device is having satellite connectivity, you may or you might not get the connectivity when you are indoor. If you are in indoor scenarios. So in that case, you may rely on the ISM band or maybe cellular band to get connectivity because cellular and ISM band can operate very well even when there is no line of sight.
Yeah. Any other point?
communication line of sight is from?
Most of the time, yes.
Any other point? Any one of you? If not, let's have a short break and we are back at 4 o'clock. 4 o'clock, he said, no? We are back at 4 o'clock.